Okay, this is related to understanding the routing protocol. First of all, what's a routing protocol is? A routing protocol is a set of rules and algorithms. So if you look at here, rules and algorithms that routers use to communicate with each other and determine the best path for data to travel across the network. Now, a few things from here. The first thing, it is used by routers. Communicating between whom? Communicating between each other. That means it is talking about a communication between router to router. And what they do through communication, they select the best path for data to travel across the network, across a network. Now look at here very carefully. You will need routers and they will try to determine the best path. When I say best path, what does it mean? It means there are multiple paths. There are multiple paths, and for example, you can take a plane, you can take a car to a destination. So which one would you take? A plane, which is faster, but of course expensive. But here what it means is there are multiple paths and you select the best path. Routing protocols dynamically build and maintain routing tables by sharing the network information between the networks. Now this is very important. There should be a routing table, and the routing table is like your phone book. So you will be able to see all the destination routes in your routing table. Okay, so it will be show IP route is the command for the routing table. Now, why do we need a routing protocol? Without routing protocol, network management would be extremely limited. Okay, now first of all, there are other reasons like route discovery. Automatically you know like the destinations. Like for example, if you look at here, we have three routers, R1, R2 and R3. So R3 knows some information and he will advertise the information to R2, and R2 will advertise those information to R1. So R1 knows that he can reach, let's say this is network 5, he can reach network 5 through R2. Like he will send the packet to R2, R2 will send the packet to R3 then. Now if you look at here, like they know, they automatically discovers, okay, that they can reach somewhere. Now that means this network N5 would be in the routing table of R1. Again, it depends on what kind of routing protocol that we use. Different routing protocols have different ways of working, so it depends on that. Dynamically updates, what does it mean? So let's say if you have added network N6 here, so it will dynamically update everyone that, hey, you know, now I have network N6 as well. So R2 knows that R3 has got N6, R1 knows that R2 knows about N6. Scalability, because with the help of routing protocols, you can break the networks into smaller pieces and you can scale up as many networks that you need. Now, best path, like if you have multiple locations, like for example, if you can reach, let's say, you can connect another router here, another router here, another router here, another router here, and then connect to N5. Let's say another router in between. So there are two ways you can reach from R1 to R3. So obviously this is the best path, apparently what it looks like, because you see it is short and the number of devices are less as well. Now these things is not like as simple as this. Depending on what routing protocol that we use, it depends on a lot of things. Okay, but just from the figure, but you need to calculate a lot of things in order to get the routing protocol to find the best path. If there was no routing protocol, then you have to use something, only the static route. So when you configure the static route, you will come to know about the static route. You have to configure everything manually, okay? Just like, think like this way, okay? So you have, let's say, you have 100 networks, okay? let's say you have network 1 to network 100. Every network, wherever they are in distributed among the routers, you need to configure everywhere everything manually. That means you will have to write hundreds of lines for each of the routers. Okay, very complex. And if anything changes, then the whole routing infrastructure will break. Okay, so you need to fix that. Otherwise, highly likely, depends on what you configure, the whole routing infrastructure could break. Okay, traffic will drop. Okay, if there is something, if the link goes down or if something changes. Not scalable, because it is impossible to manage these hundreds of lines of codes. Okay, and what happens if we have thousands? Okay, like it is highly likely you will misconfigure somewhere out of these routers, and it will end up breaking your whole network. Or every time you make change, if you make a change which is misconfiguration or something like that, it will break the whole network. Now, what is going to happen? So if you look at here, there are different routing protocols: RIP, OSPF, BGP, EIGRP. There are different routing protocols. Okay, there is IGP, there is EGP. Like, we are not going into those things. Just if you look at here, this is a network, this is a network, this is a network. So different networks, they communicate with each other with the help of a routing protocol. With the help of it can be any routing protocol. You can combine different routing protocols. Okay, there is route redistribution if you combine different routing protocols, but those are very high level things. Now, I just wanted to show you something. Let's say, for example, if I take a switch here and if I connect two computers, and I always prefer to put the IP address. Like this way, labeling those things. And let's come here, let's connect this one. Configure the IP address here. This is class C. Now, once you have configured those things, let me send a message from here to here. So if you look at here, successful. Did we configure any routing protocol? We didn't configure any routing protocol. Why we didn't configure any routing protocol? Inside the same network, you don't need a routing protocol. Okay, inside the same network, you don't need a routing protocol. But however, if we get something like this, and so now we have got a default gateway. So you need to configure the default gateway. Once you have a default gateway, you need to configure the default gateway. 192.168.1.1. Now let's come here. Let's configure the default gateway. And it will be the same default gateway for everyone. Okay, they are still red because you didn't configure the IP address on this interface. How do you configure the IP address on the interface? Come to the CLI, always type here no, enable, configure terminal, then interface fast Ethernet 0/0, IP address 192.168.1.1, subnet mask 255.255.255.0, then no shutdown. Okay, now give some time for spanning tree protocol. This will be down. Give some time. Okay, so now this is up. Let's send a packet from here to here. You see it is successful. Now if I want to send a packet from here to here, it is successful. If you come to the simulation, if you play, see, if you look at here, the packet is sent from there to there, and the packet is sent from here to here, and you get a reply. And if you look at here, successful. So inside the same network, okay, inside the same network, your packet will never reach here, because they could solve it here. Okay, so they could solve everything here. Okay, so that is why you don't need that one. Okay, now let me extend the network. Like, for example, let me grab another switch here. Sorry, I got it. Let me go. Just give me a second. Okay, so let me configure this one. We don't need this. Just if you look at here, just come here, configure 1/0. Just let me put the IP addresses first. 172.16.0.1, and let's make it 172.16.0.10, and let me put the IP address 172.16.0.10, and configure here 16.0.1. Okay, we need to configure the IP address here. Last time I configured with the command. Now I will take a shortcut, which is here, and have to make it 172.16.0.1 and no shutdown. Let's give some time. Because of spanning tree protocol, it is taking time. Okay, once everything is green, let's try something. Let's send a packet from here to here, and you see it is successful. Let's look at the simulation. That is over there. Okay, this is about this packet. So you will see here success. You see here success. Okay, so you see this is successful. The packet reached here and it came back here. Now let's delete everything. Okay. Okay, let me send a packet from here to here, and let's see what happens. Successful. Let's do the simulation. The packet is sent from here, then the packet is sent here, So if you look at here, it was successful. Now, if I take this one here, when I was sending a packet from here to here, it was successful. When I was sending a packet from here to here, it was successful. So according to my understanding, or let's say general understanding, if I can reach from here to here and it is the same router, that means from here the packet to here is should be successful, because I can reach here successful, I can reach here successful, and this is the same router, okay? So it should be successful. Now delete this one, real time. Now let me send a packet from here to here, and if you look at here, it is also successful. So sending a packet from here to here is also successful because they are on the same router, okay? Now if you look at here, come to the CLI, do exit and do exit, do show IP route. Look at here, this is a routing table, and if you look at here, this interface is directly connected to this interface, this network is directly connected to this interface. So if you look at here, this is a directly connected interface, see, directly connected to this interface, and this is a directly connected to this interface. So what happens, just remember these two. So whenever you are sending a packet from here to here, he checks for the destination. Sorry. If you come here, whenever you want to send a packet from here to here, the packet first goes here. Of course, it goes to the switch, then comes here, and he checks the destination is 172.16.0.10, and he knows that from the routing table. So if you look at here on the routing table, this network is already there, 172.16. So this IP address is a part of 172.16.0.10 is a part of this network, and he knows that he can send through this interface, fast Ethernet 1/0. So if you look at here, from the routing table, he can send to the fast Ethernet 1/0, okay? And from here, it goes here, okay? So this is how it works. Now, they are directly connected interface, okay? Now look at here very carefully. Let me introduce another router. Let me connect this one to fast Ethernet, let's say 0/0, and let me take this interface here, and let me select serial because I have run out of those ports. Serial 2/0. First of all, let me remove this one, fast Ethernet 0/0 is this, 1/0, I don't need this one. Turn it off and remove this address. Come here, and if you look at here, fast Ethernet 0/0, come here, configure the IP address here, turn on the interface, this is done. Now if you look at here, I do not have any IP address between these two interfaces. So I need to introduce another IP address between the interfaces. So let me bring here 1.1.1.1/30 and 1.1.1.2/30. Okay, now let's come here. Let's come to, of course I used here VLSM, but this is not something I'm discussing VLSM here. Let's come to serial 2/0 and let's make it 1.1.1.1. Subnet mask will be 255.255.255.252 if I'm not mistaken. Okay, and here I need to make it 1.1.1.2 and 255.255.252. Turn it on. Okay, now let us have a look at it. Take this one here, send a packet here, sorry, let's remove everything, send a packet from here to here, successful, right? And let me draw this one here. So here to here was successful. Here to here is also successful. So here to here was also successful. Sending packet from here to here is also okay. Let us see if we have made a mistake here. 1.0, 0.1. So let's come here. Let's see fast Ethernet 0/0. Everything is 0.1. Everything looks good. It failed. Let's try again. Here to here. You see, successful. Okay, first time failed and all these things happens. Okay, first few packets could fail, but eventually it will work. Eventually doesn't mean that you need to stay for the whole year. Okay, like if obviously if there is a configuration mistake, then it will not work. So according to the logic, if I send something from here to here to here to here, it should be successful. However, it will be unsuccessful. Let's try. It doesn't matter how many times you try. So let's try from here to here. Failed. Wanna try more? Try more. Wanna try more? Try more. Wanna try from this one to this one? You see, failed. Wanna try from this one to this one? Successful. Okay, so from here to here it failed. Why it failed? Let's go to the simulation, start. Let's see. So you are sending here to here, then it goes there. Now you see over there it got denied, over there it got denied. Okay, and it says that it is unreachable. Okay, see, red. Okay, now come to the real time. Why it got denied? Let's come here. If you see the routing table, show IP route. So if you look at here, 172 is not present here. So the directly connected interface is this 1.1.10, and if you look at here, the directly connected interface is this. These two networks are directly connected. Okay, so if I just take this one as a screenshot here. Okay, so if you look at here, this is a network this is another network, and they are directly connected. And this network has some IP address. Of course, I know that it is very limited because it is /30 and this is /24. It has a lot of IP addresses. I'm not teaching here IP addresses. So any IP address from this network, he will be able to send through this port, and any IP address from this network with /30, he will be able to send through this port. But whenever you are sending a packet from here to the other PC over there, your destination IP is 172.16.0.10. And is there any entry in the routing table for 172.16.0.10? No, there is no entry in the routing table for 172.16.0.10. So in this case, what's going to happen? He will have to drop the packet. He can't send it over there. Okay. The routing protocol will update, this router will update this router. Hey, I know about 172.16.0.10, 172.16.0.0 network, so that he knows that this router knows about that one. Now let me configure a random routing protocol. Okay, let me configure a random routing protocol, show you how the routing protocol works. Okay, so this is just, I'm not explaining the routing protocol, I'm just configuring a random routing protocol. Okay, so I need to go to configure terminal. So if you look according to the definition, communicates with each other. That means with one router to the other router. Is that clear? So if you think about, it's not on the same router, it says one router to the other router. Okay, so router RIP version 2 network. I'm not explaining anything, sorry. Here I'm just showing you 192.168.1.0 and 1.1.1.0, then no auto summary. And also if you come here as well, you need to configure routing protocol, the same routing protocol on the on both the devices. Okay, router RIP version 2 network 172.16.0.0. Made a mistake here. And also network, I can write shortcut, no auto summary. Now once I have configured, give some time. First check the routing table. Okay, this was the previous routing table. Take a snapshot of this routing table so that you can compare them. This was the previous routing table, right? Beautiful. Now come here, do the same thing again. Show IP route. Now look at here, you see the difference. The difference is very obvious. So if you look at here, you can see this 172.16.0.0/16 via 1.1.2. Okay, so via 1.1.2. Okay, now does he know about 1.1.2? Of course he knows. Okay, first of all, you see the difference between these two things. So if you look at here, you do not have this 172, now you have this 172. Okay, now let's come here. So if you look at here very carefully, I know about this 172, about this networks, any IP address in this network, and he's connected via 1.1.1.2. Now the question is, for this router, is there any 1.1.1.2? No. He has 1.1.1.1, he has 192.168. However, he knows about 1.1.1.0 network, right, which is /30. So /30 includes this IP address. So this IP address is included in /30. Okay. So that means he knows about this IP address as well. Like he will be able to find about this IP address through this network, sending through serial 2/0, sending through serial 2/0. Okay. Now, if you look at here, let me send a packet from here to here, and you see it is successful. You see it is successful. Now let me delete everything. Let me send a packet from here to here. Let me show you the simulation. And after that he will send a reply packet that he has reached. So if you call someone, if he doesn't reply, then how you understand that he's dead or alive? So this is what is happening here. See, successful. Okay. So this is what is all about the routing protocol. And if you look at this routing table as well, you will find that he knows about all the networks. Like it's all about, like everyone knows about everything now. Show IP route. So if you look at here, he knows about this 192.168.1. Through the R means RIP routing protocol. R means RIP routing protocol. Okay.